Okay, I don't know about you, but I'm tired of waiting, so let's go ahead and get started. My name is Kirtland. I'm a program manager with the COM team, and I think this talk may have been overpromised because I can't believe you all really want to hear about this. But just in case I'm wrong, I have been getting a lot of the same questions over and over and over again, so I thought I'd just answer those up front. COM Internet Services will ship in NT4, SP4, in case you really wanted to know. Writing components for COM Plus, exactly the same as what you do today. And you're going to say, but last year you told me something different. In those articles you wrote, you said something completely different. Don't believe those. Just forget all that. What about that book you were writing? Next year, if my brain doesn't implode first. I've just gone through the experience of writing one book, and I'm really on the edge there. So my brain is full. And if I can stuff anything else in, I'll write inside COM Plus. And also, last year I gave a presentation that sounds a lot like this. Forget it all. We're going to start from scratch. Okay, now, start believing me now. The goals of this talk are to help you understand how COM Plus relates to COM and MTS. It's also trying to describe how the underlying infrastructure works so that you can understand how the features fit together. If you look at each of the features individually, it's not always obvious. I'm also going to talk a little bit about the implications of using some features, because it turns out that when you use feature 1, you can't use feature 2, for example. I'm not going to give you an in-depth discussion of every feature. If you look at the slides that you've got on your printouts, you're probably wondering how I'm going to get through all those in an hour. I'm going to talk really fast. I'm not going to talk about how to write code. The samples that I have are we're going to look at the very simplest scenario, creating objects, calling objects. And this is not undocumented COM Plus. I'm not giving you enough information that you can do something that we're going to have to support later on. The assumptions are that you already understand COM and MTS pretty well. If you don't recognize the words on this slide, you may be in trouble. So, I hope some of those are familiar to you. And just to simplify things, we're only going to look at DLL servers, and we're not going to look at the specifics of any particular service. So we're just going to look at the real low-level stuff from a high-level perspective. We're going to do a very quick review of COM and MTS today, about 5 minutes. And then we're going to start looking at the COM Plus architecture. And after that, we'll look at some of the new ways that you can call methods in COM and COM Plus in NT5. Things like non-blocking calls and call cancel, other things that are at the low level of COM. And finally, we will have the obligatory call to action. And hopefully there'll be some time for questions at the end. So for our review of COM architecture, what we're going to look at is object creation, in process, and remote for DLL servers. We'll look at calling an interface method, and we'll do a very quick review of apartments and threads as they exist today in COM. So here is my program manager type sample code. Co-initialize, co-create instance, and call a method. Here's what happens in COM today in the in-process case, assuming that we're in the same apartment. The client calls co-create instance. And for those of you wondering how you're going to remember what these little numbers mean, if you print out the slides with note pages, all the numbers are listed on the note pages with what they refer to. So the client's going to call co-create instance. Co-create instance is going to do some work in the COM runtime to call the service control manager that will go out and look in the registry and find the mapping between the class ID that you've requested and the DLL that needs to be loaded to provide this component. The component will be loaded into memory in the client's process. We'll create the class factory, and the class factory will be asked to create the object. The object will be created, and an interface pointer will be returned to the client. That should be real familiar. In the remote case, it's a little bit more complicated. Client calls co-create instance. The runtime asks the scum to locate the server, looks in the registry and finds this app ID thing that has a remote server name instead of having an in-proc server 32 key. The scum will ask the scum on the remote machine to get in the act, and that will look in the registry, locate the class ID, the server that needs to be loaded, and we'll also see under the app ID key that you want to run within a particular surrogate, the process that you're going to load the DLL into. If you don't specify a specific surrogate, we'll use the standard COM surrogate. So after we found that information, we're going to load the surrogate process, load the component, assuming that you have the correct launch permissions. At that point, we go through the work to create the object and again return an interface pointer back to the client. Now, calling an interface method in COM is pretty straightforward. In the in-process case, in the same apartment, it's a direct function pointer method call. In the local case, you're going through proxy and stub. So COM gets in the act and does some work for you to make the illusion that a client is calling an in-process object and that the server is loaded in process. And the same thing happens in the remote case, except that you have to talk to a remote machine. What's not shown on here, because I couldn't figure out quite how to squeeze it into the diagram, is when you go across department, you are still going through proxy stub. And again, you're going to have some security checks going on when you make an interface call. So just a quick review of apartments and threads. Today we have two types of threads. We have an STA thread that synchronizes based on Windows messages, and we have an MTA thread, which doesn't have any implied synchronization at all. We also have two types of apartments. We have an STA, or single-threaded apartment, that is associated with a STA thread for the lifetime of the apartment. And objects that are created in that apartment or on that thread are always called on that thread. MTA apartment can have multiple MTA threads associated with it. You can have one MTA per process and multiple STA apartments per process. So that's where we are today in COM. Now we're going to look at the same thing in MTS, but we're going to do a little bit different in that we're going to look at object creation from a base client, one that's not running in MTS, and then object creation from a component or an object that's already running in MTS. And then we'll also look at calling an interface method. So the sample code's a little bit more complicated. The base client's the same. It's going to create a sub-object. And the implementation of that sub-object is going to use the object context, the getObjectContext method in MTS, to retrieve a context object that you will use to create the sub-object by calling createInstance. Once the sub-object is created, you can call methods on it. Okay, so from the base client, the client will call co-createInstance. COM runtime will ask the scum to find the server. When you look in the registry, there'll be a local server 32 key that points to the MTS process, and it will have a package identifier associated with it. When this happens, the MTS surrogate will be loaded. The MTS executive, which is a DLL that does all the actual work of MTS, will be loaded. And the components in the package will be loaded. Now the co-createInstance implementation will ask for a class object to be created. The actual class object will be created in the component, but that's not what gets handed back to the COM runtime. What really gets handed back is a class factory wrapper. And this wrapper lets MTS get in the middle of object creation requests so that it can do its service work, the work it needs to do to implement particular services. So once a class factory wrapper has been created, that will be returned to the co-createInstance implementation. It will call createInstance to create an actual object, but the real object doesn't get created. What gets created is a context wrapper that has an object context associated with it. The context wrapper exposes the same interfaces as the actual object. And that interface pointer is what gets returned to the client. So from the client's perspective, it thinks it has a pointer to an actual object in your component. But what it really has is this wrapper in the MTS executive that can get in the middle of every method call and do some work. It's a really cool echo effect going on here. So object context. The context has information that MTS needs to know to do the service work for transactions and role-based security and the other things that MTS does for you. The information to populate that object context is determined from the MTS catalog, which is established by the settings that you set using the MTS administrative tools. Now, once you have an object, that object can also create subordinate objects, and it can flow context information from one object to the next. When it does that, instead of calling co-create_instance, it's going to call the object context create_instance method. We'll go through the same process of doing the work of locating the server and creating the class factory as we did on the previous slides. The class factory wrapper will look at the object context that already exists and information in the MTS catalog about the new class that you're trying to create, and use that to create context wrapper for the new object and an object context with the appropriate properties for the new object. So some of the properties might be different. For example, if your class is marked as requires a new transaction, then the transaction ID for your subordinate object would be different than any transaction that had already been established by your master or calling object. And once you have the interface pointer in the context wrapper, that can be returned to the object. So what happens when you call an interface method? When you call the interface method the first time, the object doesn't really exist yet. So we use just-in-time activation to create the real object. The context wrapper will use information in the object context, create the actual object. Once it has an interface pointer, it can then call to the real object. And because you have this context wrapper in the middle, it can do whatever work it needs to do the transaction support you get, to do the synchronization support that MTS provides, to do the role-based security checks. So that's what we have today. Now we're going to move on to what we're going to do in the future. First of all, I want to talk about what COM+ is. Hopefully you've heard this a few times already. It's the unification of COM and MTS and some extensions. So we have extensions to the base COM features that you have today. We have extensions to the services that you have today. And we have new services. Again, there's minimal impact on the way that you create components today. You still have to write a class factory. You still implement interfaces. You still implement iDispatch if you're a C++ programmer. And the remoting architecture doesn't change either. So we're still using DCOM. And we're not going to talk about the remoting layer because that doesn't change. We're going to talk about this middle stuff, which is how you create objects and how we get in the middle of every call to provide automatic services to you. So first I want to go over some terminology. COM+ applications are the evolution of MTS packages. You have library applications that run in process and server applications that run in the COM+ surrogate. So they're just a way to group components together. COM+ classes fall into two categories. A class is the thing that has a class ID associated with it. Configured classes are installed in a COM+ application, and they can use COM+ services. Unconfigured classes are all the other classes that you might have. So things that use MTS today are going to be configured classes in COM+. Things that don't use MTS today will probably start out as unconfigured classes until you figure out what services you want to use. We have the same thread types in COM+ that we do in COM. So there's no change there. But we add a new apartment type called the neutral apartment. And this is a little bit different from the existing apartment types because your objects are going to execute on the caller's thread. So if they're called from an STA apartment or an STA thread, they'll have STA synchronization semantics. If they're called on an MTA thread, they're not going to have any synchronization because that's the semantics of MTA threads. Now, one of the things that's really confusing about COM is figuring out what the threading model key has to do with where your object gets created based on the apartment type of your calling object or your creating application. So this chart shows you for a particular creator's apartment model and a particular threading model for your class, what type of apartment and which apartment your object will be created in. And I'm not going to go through that. You can read it later if you really, really, really want to know. Same thing for marshalling. It's confusing to figure out when exactly things are going to be marshaled, and this chart will tell you in excruciating detail exactly when your objects will be marshaled. So now we're going to get into the rapidly approaching math or set theory portion of the talk. A domain is an independent aspect of an execution environment. What does that mean? It means a part of the services or an aspect of the way that your components are going to run. For example, a transaction. One particular transaction is a domain. One particular apartment is a domain. If you have two transactions, they are different domains. Objects that have the same properties for a particular part of your execution environment belong to the same domain. So everybody who's in the same transaction is part of the same transaction domain. And domains can arbitrarily nest. For example, you have a machine, it has processes, it has apartments, those are nested. You can have intersections. You can have transactions that span apartments, for example. A context is an intersection of domains. So a set of all of the properties of your execution environment, if all of the properties are exactly the same for a set of objects, they'll live in the same context. Every object in COM+ lives in a context. This is different than COM today. COM, there's no notion of context. MTS, every object has a context associated with it. In COM+, every object has a context associated with it. Objects from unconfigured classes go into something called the default context, which really doesn't do anything for you, it just is there. And the non-default context is where configured classes are going to live. And there will be many non-default contexts in a typical application. Context is the basis for the COM+ services. So this is how the services go in and implement particular policy based on differences between the properties of one object and the properties of another object. And we'll talk about this more in a minute. So here's a diagram of what I'm trying to talk about. We have processes, there are apartments in the process. Contexts live within a particular apartment because one type of context is the apartment, or one domain is an apartment. You can have multiple contexts within an apartment, and you can have domains that are within one apartment, within one process, or across machine boundaries, or across process boundaries. Now you're probably really confused, because I think I just confused myself. Okay, we're going to go through the same source code for COM+ as we went through for MTS. So we're going to create an object from a base client, and then create an object from that object we just created, and call a method. For the base client case, the code is the same. You call co-create_instance. But for the component, things are a little bit different. Now that we're all integrated into the normal COM runtime, we don't have to have this special method that you call get object context create instance. You can just call the normal co-create instance, and it will create an object. It will have a context associated with it, and the context will flow properly. So the code that's commented out is what you would have in MTS today. And the code that is not commented out is what you would have in COM+. Okay, so the client is going to call co-create instance from the base client. Now we're going to have these things called activators get in the act. We've componentized the process of creating objects using something called activators. And there can be a set of activators that get invoked during the creation of a particular object. So the runtime is going to ask this chain of activators to do whatever necessary to create the object. One of the activators is going to go out and look at something called the COM+ catalog. And the catalog will find the registry information, including where the server is located, like we have in the registry today, and all of the attribute type information that you specify in the COM+ Explorer. We'll talk about the catalog on the next slide, but the key thing is that for legacy reasons, we're going to have two separate stores, a registry and something called regdb, that both need to be queried. And by encapsulating that behind a component, this catalog component, the activators don't need to worry about that. They can just query the catalog. Once they've figured out where the object should be created, a context will be created. The component will be loaded within that context, the class factory will be created, and then the class factory will be asked to create the object. So now we have an object living within a context. And the interface pointer can be returned back to the client. In the remote case, things are pretty much the same, except that after we've called co-create instance, and we start looking through the COM+ runtime, and the activators on the local machine get in the act, one of them realizes that we need to go over to a remote machine in order to finish creating the object. So it will ask the runtime on the remote machine to start up its sequence of, or its chain of activators, and they'll continue the process of creating the object. And they'll look at the catalog on that remote machine. The surrogate process will be created. The context will be created in that process. The component will be loaded. Object will be created. And the interface pointer will be returned. Notice that this really combines what we had in COM and what we have in MTS today. And we've made the activation process, the process of creating an object, a little bit more flexible, because instead of trying to add a bunch of attributes or parameters onto the API, co-create instance, and making that even more complex than it already is, we can use attributes that are stored in the catalog to specify information about services. And the activator chain can figure out what those attributes mean and do the right thing to create the object in the correct place. We don't have to specify all these parameters during object creation. And like we have in MTS today, we create a context, and every object is going to live in that context. Okay, so the COM+ catalog is the way that we unify and extend the registration process in COM and MTS. And the activators are going to use the catalog rather than look directly at the registry or the registry database. The registry is HKey classes root, and that will typically be used for unconfigured classes. And every component that you write today puts registry information into HKey classes root. So for legacy reasons, we need to continue to support that, probably for a real long time. The registry database is where the configuration information about the service attributes that you want is stored. And if you went to the admin talk earlier today, you may have heard more about the process of creating those attributes and how they get stored. The admin tools are available today for creating regdb and the information in there. In the future, you'll be able to create something called self-describing components. And I believe that you may have seen a demo of Visual C 6.1 that is able to do this. So metadata will actually be stored with your component that can then be read into the registry database when you install your component into an application. Self-describing component has a type library like it does today that describes the class, the interface, and the method signatures. That's the same as we have in COM. Component library has the attribute and registry information. So things about particular services, and things like the threading model, component categories that you might implement. For real old OLE type things, we have file extension. I don't know how many people really use that for anything anymore other than loading the proper application when you double click on a file. But in order to have these self-describing components, you need to have developer tool support. So right now, there's really no way to create them until we get the next version of tools out. The tools use interfaces called iMetadata emit and iMetadata import to generate and read component libraries. Okay, so let's go back to activators for a minute. This is the way that we make an extensible architecture for object creation. And some of you may be thinking, ooh, I can make an activator now. And you would be wrong. Because we're not going to tell you how. We're going to try it out in COM+ 1.0, and we're going to see how it works. And then after you've told us how it doesn't work, then we'll think about whether we want to let you do anything with it in the future. The activation chain is going to be responsible for figuring out where the object gets created and what its context properties need to be. So it determines the environment that the object is going to live in. We provide the system activators, and we define the order that they get called in. So we are in control of this. So here's a picture of how this works. You have activators at various phases of the object creation. You have activators associated with the context. You have activators associated with a process on the client machine and on the server machine. And then if you're crossing a machine boundary, you're also going to have machine-level activators. An example of a machine-level activator would be the load balancing activator that can actually say, I don't want to create the object on this machine. I want to create it over there. So it can change the location where the object is going to be created. Now, context, again, is a little bit different than it is in MTS. The context contains a set of context properties. We know what they are, but we're not going to tell you about them. The context properties can flow from the client or the caller to a new object context, the same way that they do in MTS. And once you've initialized a context, it cannot change. So you can't have a bunch of objects that are in a context and then decide, oh, these are just going to be part of a different transaction. Once you've established the context, it's fixed. So let's see if we can figure out what happens when we activate from a component. The object is going to call co-create_instance. And that's going to ask the activator chain to start its work of creating the subordinate object. Now the activators are going to look at the current context of the caller to establish a set of prototype context properties. It's going to just blindly copy all of the context properties from the caller. Then the activator chain can look at the information from the catalog and the work that it needs to do during activation to modify the properties of the prototype context. So for example, if a transaction activator sees that you have a requires new transaction, then you wouldn't take the transaction identifier from the caller. You would create your new transaction property, a new value for that. Okay, if all of the properties in the context, once the activator chain has completed its work, are identical, then we're going to create the new object in the original context. So if there's no difference, the object will get created in the caller's context. And the interface pointer will be returned back to the caller. If, on the other hand, the context properties are different, then we have to go look and see whether there's an existing context that has the properties that were set in the prototype context. If we find a context that fits the bill, we'll use that and create the new object in that context. If not, we need to do the work to create a context that has the appropriate properties. Once the context is found, we can load the component, create the object, and return the interface pointer. Everyone kind of with me so far? Nod, shake your head. Kind of makes sense? Okay. Activation takes care of creating the object. Another new term that you've probably heard a lot about is interception. This is what happens on a method call. If you have objects that live in the same context, everything about the environment that those objects live in is identical. So we don't need to do anything. We can just make a direct call from one object to another. If, on the other hand, there's a difference between the context of the caller and the context of the callee, it's likely that we need to do some work to implement the semantics of one or more services that you've elected to use. And the way that we do that is with something called policies. We'll talk more about what policies are in a minute. But basically what happens is when you cross the context boundary, we will fire off a series of events during the course of the call, and the policies receive these events and can do some work to implement the semantics of that particular service. When we're going across context boundaries within the same apartment, we don't really need to do the full marshalling. We don't have to package up all of the call parameters and stick them into a standard format and unmarshal them on the receiving side. All we need to do is make sure that the policies get all of the events and do their work. On the other hand, if we're going across department, cross-process, cross-machine, then we do need to go through the proxy stub. And in this case, we've extended the proxy stub architecture so that it understands how to deliver policy events and policy information across these boundaries, from the proxy to the stub and back. Okay, so a bunch of definitions that will hopefully clarify that picture. For every context property, there's likely to be something called a policy maker. And oddly enough, policymakers create policies. So we use a policymaker, or a set of policymakers, to build a policy set that is going to describe what needs to happen when you call from one context to another context. Every policymaker in the calling context and every policymaker in the callee context can contribute policies to the policy set. And we create this the first time we unmarshal a reference from one context to another. Now you might be thinking, that sounds like there's an awful lot of overhead going on here. So we do try to make it pretty efficient in that, although there's a cross-context reference associated a policy set associated with every cross-context reference, for all of the references between any two given contexts, we can share the policy set. So between context 1 and context 2, all calls are going to share the same policy set. And that policy set is going to reflect the difference in properties between the two contexts. There's a difference in security, or difference in synchronization, a difference in transaction, then those services would contribute policies to the policy set. When you make a call across a context boundary, like I mentioned before, there's going to be a set of policy events delivered to all of the policies in the policy set. And this is how we do composition. It's probably a term that you've heard a lot in various MTS and COM+ talks. It means that we can have individual services and we can combine them together, and they will work, hopefully, together well. So you can have transactions and security. You can use load balancing and security and transactions. You can use all that with synchronization. I hope I didn't say a combination that doesn't really work. I think I'm safe there. A policy object provides the semantics for a particular domain. So it knows how to do the work required for synchronization or for transactions. The events that the policy can get On the client side are we're making a call and we've returned from a call. And on the server side, it's we're entering and we're leaving the object. We're entering a call and we're leaving a call. And the client and the server can pass some information back and forth to inform the other side what's going on and try to influence what happens in the implementation of your domain semantics. So for example, a synchronization policy that we have where you can say, I require synchronization, I require a new synchronization, I support synchronization, or I don't care about synchronization. That actually, when the server receives the onEnter event, the policy for the synchronization service is going to acquire a mutex. And once it's acquired the mutex, it's the only thing that can do work within that synchronization domain. Because the next guy who wants to enter a particular call is going to have to wait until the mutex is available again. And when you leave the call, you're going to release the mutex so that the next guy can do his work. Okay, so a quick recap of activation and interception. Hopefully this kind of made sense. During instance creation, the activators for a particular class ID determine the new object's location and the context properties. Activation, object creation. The first time we unmarshal a reference from one context to another, the properties of the context are going to act as policy makers and add policy objects to a policy set for the difference between those two contexts. During a call, COM+ is going to deliver events to each of the policies, and the policies can do work during those events to implement the semantics of a particular domain. Okay? We will now take a break for a couple of seconds just so your brain can absorb that. And I can get some liquid in my throat. The services, all of the services that are being discussed in other talks, which I have listed here, build on top of this architecture. So services are implemented as either or both activators and policies. Talked about the synchronization policy that acts on each call. And we talked about the load balancing activator that helps determine where a particular object is going to be created. And with any luck whatsoever, some of these other talks will go into a little bit of information about how the particular semantics of the service are implemented. And most of those talks are tomorrow. Okay, now we're going to switch gears a little bit and talk about extended calling models. COM has always had this synchronous model where the client and the server have to be running at the same time, and you have to know about the interface that you're calling. And if you don't know about it, you're in big trouble because you're not going to know how to make the call. And you have to wait for the call to complete before your client can continue. In COM+, we're adding some additional models that can help you work around the problems that that synchronous model can cause. The first is some asynchronous options, and there are two. One, we're now calling non-blocking calls. We used to call it asynchronous COM, but we're going to call it something different so we can call the combination of the two asynchronous COM and really confuse you. Okay, good. I'm glad. Our plan is working. We tell you everything, but we don't necessarily tell it to you in a way that you can use it. The other asynchronous option is queued components. Queued components use MSMQ to transport calls from a client to a server, a caller to a callee. And so that will work in a disconnected scenario. And there's a talk sometime, AS10, is a talk about queued components. And I hope it hasn't happened yet if you're interested in it. Another option is events, publish and subscribe event model. And this, again, also has a separate session, so I'm not going to talk about it. But hopefully that session will answer any questions you have about events. A third option is COM pipes. And we're going to talk about these. They're kind of neat. If you have a lot of data to transfer from your callee to your caller or vice versa, instead of having to transfer it all in a big block or devise some protocol to synchronously poll for more information, you can use a pipe to pull and push information between the caller and the callee. And finally, we have something called lightweight handlers, which is an easier thing to use than custom marshalling, although if you look at the slide that I've got, it might not look that way. Okay, so first, non-blocking method calls. This is what was formerly known as asynchronous COM, and it will only work with unconfigured classes. So if you want to use any of those cool COM+ services that we're telling you about in all of the other talks, you can't use non-blocking calls. Please don't ask me why or when that will be fixed. In non-blocking method calls, the client and the server are connected. This is not something where you can have your laptop that you're carrying around all week, and then you go back to the office and plug it into a network, and magically all of your COM calls complete. That would be queued components. We have two models for non-blocking method calls. The first is fire and forget. You don't care if the call ever gets there. You don't care what happens when it gets there. All you want to do is make calls. And the second model is call and reply. You want to make the call and let the server go off and do some work, and then later you do want to get some results back, but you don't necessarily want to be blocked waiting for them. So that option is also available to you with non-blocking method calls. The nice thing about this is that you can specify an attribute in your IDL, assuming that you have IDL, which is the async_UUID attribute. And when you do that, middle is automatically going to generate an async interface for you. What this async interface has is it splits every synchronous method into a begin and a finish method. The begin method takes all the in parameters, and the finish method gets all of the out parameters. So that gives you a way to get the out parameters back. Okay, now we're going to describe how this works for the case where both the client and the component support non-blocking calls. And we're not going to worry about marshalling at all. We're just going to show what happens for the non-blocking call case. First of all, you'll notice that the object in this component has both an interface that looks like it might be specific to the component and something called iCallFactory. iCallFactory is a new standard interface in COM+, and it is used to create something called a call object. Every call can have a call object associated with it. So what happens is the client is going to ask for the iCallFactory interface on a particular object, and then it's going to call a method called createCall. The implementation of createCall is going to create a call object that implements the asynchronous interface that corresponds to the synchronous interface provided by your object. And it also has to implement another new standard interface called iSynchronize. And there are some other optional interfaces that your call object can implement, but those are the two that you have to implement. Okay, so the call object is going to return a asynchronous interface pointer to the client. Once the client has this interface pointer, it can call the begin method for whatever method it wants to call. When it does that, it can continue on and do its work. The call object is actually going to implement the method. It will reset the synchronization and then start doing its work. And when it's done doing its work, it will signal through the synchronization interface that it is done. If the client has elected to wait for results, it can wait on this iSynchronize interface on the call object for the signal event that the work of the method is done. And then it can call the finish method to get its out parameters back. So this is slightly more complicated than the synchronous calling case where you just call a method and you're done with it. Some things about call objects is that they are specific to a particular object and a particular asynchronous interface. So you can't just create one call object and then make lots of calls on it. You can only have one outstanding call on a particular call object. So if you want to fire off a bunch of asynchronous calls at once from your client, then you're going to have to create a bunch of call objects and keep track of them and wait for them if you want to get results back. If you are within an apartment, the client and the component have to agree on the calling model. They either both have to choose non-blocking method calls, or they both have to choose synchronous. If, on the other hand, you are going across apartments, across process, across machines, the proxy stub architecture gets in the way, and we can correct for the mismatch. So if the client wants to make asynchronous calls, but the server only supports synchronous calls, that's fine. The proxy and the stub will do the right thing to make that happen. Conversely, if the client only wants to make synchronous calls, but the server object supports asynchronous, then we'll do the right thing there as well. The proxy stub, the proxy supports iCall factory and does the right thing there. The stub will try asynchronous, or the non-blocking interface first, and then synchronous the first time an object method is called, to see how that particular object wants to handle its calls. And there are some examples on the platform SDK that show how these various combinations work for non-blocking method calls. So the SDK that you're getting on your DVD that you can't read will have everything you need to know. Probably going to get in trouble for that remark. Oh well. Okay, so I mentioned the asynchronous interface, or isynchronize. Isynchronize has the things that you would kind of expect an interface that wrapped events to have. It has signal, reset, and wait. And the cool thing about this is that the wait uses a new API called co-wait for multiple handles that maintains all of the guarantees that the COM threading models have. So if we need to do message-based synchronization, we will do the right thing and spin a message loop. We also provide some standard synchronization objects. The first is class ID standard event. I know you probably can't read what that little thing says, but in the standard event, you supply a Win32 event that you want to wait for. But you're providing this nice COM-based interface that you can use to wait. And you can call isynchronize wait so that you're maintaining your COM threading guarantees. We also provide an object called class ID manual reset event. And in this case, we create an unnamed Win32 manual reset event for you. And finally, we have class ID synchronized container that you can use to register a whole bunch of isynchronize interfaces that you want to wait for as a group. So if you've got a lot of outstanding calls and you want to wait, you can do that. And I believe there is also a sample on the platform SDK that shows how these work as well. The next thing I want to talk about is call cancellation. It's something that people have been asking about for a long time is, well, I have this method call and it seems to go on forever. How can I change the timeout? We're not going to let you change the timeout, but we are going to let you cancel the call. And the diagram that I'm showing here is the COM provided support for canceling standard marshaled calls, which is pretty much automatic from your standpoint. We provide some APIs and standard interfaces to do this. You can also support call cancellation from custom marshaled objects or objects that are supporting non-blocking calls by implementing iCancel method calls yourself. Okay, so the client application is going to make a method call. In this case, it's a synchronous method call. When it makes a method call, the proxy is going to register the current cancel object with COM. And the proxy supports this interface called iCancel method calls. And that will get registered in some hidden place in the COM runtime library. If the client wants to cancel a call, it will call an API called co-get-cancel-object that retrieves an iCancel method calls interface pointer. And the client can then call the cancel method on iCancel method calls. Now, this is just a request from the client to cancel the method call. And from the client's perspective, the call will appear to be canceled. But there's no guarantee that the server will actually stop doing any work at this point. So the server may continue on thinking that there's somebody listening, even though there isn't. However, the stub is going to maintain, on the server side, a corresponding cancel object. And the object itself can query that and ask to see whether its method call that it's working on has been canceled. And it uses an API called co-test-cancel to do that. So this gives you a way both from the client side to say, I want to cancel this particular call, and it gives you a way on the server side to find out whether anyone's paying attention to you, at least whether they have stopped paying attention to you using this call cancellation service. Okay. The next section is about about COM pipes. These are very similar to RPC or DCE pipes that let you transfer a large block of data without blocking in this synchronous method call forever. There's a bunch of new interfaces called iPipe byte, iPipe long, iPipe double, and any other type that you might want to have. And you might imagine that these let you pull an array of that particular type from the pipe source or push data of that particular type to the pipe source. And these also support non-blocking method calls. So you can have synchronous or non-blocking, or you can have, did I say that right? You can have synchronous or you can have non-blocking calls on your pipe interfaces. So what this is really doing for you is that it's trying to do read ahead and write behind using asynchronous calls behind the scenes so that from the client's perspective, there's always some data that is readily available in this pipe that you can just grab. So it tries to keep one read ahead, getting the next set of data that's available in the pipe so that you can have some faster response and you can just pull the data out rather than waiting for this huge block of data to come over at one time. And we keep this little buffer, which is what that little square is trying to demonstrate. There is an example of this as well on the SDK. Trying to save some time for questions here, so I think we're actually going to do that. The last thing is lightweight handlers. This allows you to specify as a server a handler that you want to load into the client's process space. So this is useful if you need to do some special processing for a particular interface, if you want to cache some information, maybe if you want to do some fancy tweaking so that interfaces look like properties on one side but are kind of efficient for network transfer going back to the server machine. This only works for the connected case. Server and client are connected. This is different from, if you remember way back to OLE compound document days where there was a handler that got created, but it didn't load the server immediately. It only activated the server when it really needed to, which could cause some interesting side effects when you tried to do something in your server, but the standard handler didn't do it, and the standard handler was intercepting all of the work and doing it for you instead of passing it on to your server. We use an existing interface on the server side. So the server object needs to implement iStandardMarshalInfo so that it can specify the name of the handler class. And we also have a new API called CoGetStandardMarshalEx, and that's used by the proxy and the stub to integrate your handler into the proxy stub architecture for standard marshalling. And that's how it works. This was not easy to draw. I hope you appreciate it. Okay, so I have my crib notes here that explain what this shows. This is the no extra data case, where you're not trying to pass any more information about a particular object or a particular call for your lightweight handlers. Now, we've shown on the previous diagrams that you have an object proxy, and we've shown it as one thing. But in reality, it's made up of many smaller objects that are aggregated together, and that's on the left-hand side. There's this identity object that makes sure that there is a single identity. And there's the proxy manager and the interface-specific proxies that you're familiar with, hopefully, today. This is the way marshalling works today. What we're letting you do is stick your handler in the middle of that so that you can do some work. You, as an implementer of a client-side handler, use the CoGet Standard Marshal EX API to aggregate yourself into the standard proxy. And it will take care of setting up all of those arrows for you. On the server side, your object is going to implement iStandardMarshalInfo, and the stub manager is going to call CoGet Standard Marshal EX to make sure that the correct handler is being loaded into the proxy. Now, if you want to pass extra data on the method call, if you want to marshal extra data into the marshalling packet, then both the server and the handler need to implement iMarshal. And then you delegate the marshalling of the standard part of the packet to the standard marshaller, and you take care of the extra data that you've passed along. And there is also a sample of this on the SDK. So we have samples of all of the extending calling models that I talked about here under the COM part of the sample tree in the platform SDK. So to summarize, COM Plus unifies the COM and MTS architecture. We have an extensible architecture for activation and an extensible architecture for interception. But we're the only people who can extend it right now. We're also extending COM and MTS by providing additional services that build on this unified architecture, and we're providing additional ways for you to call into your objects. So things you can do. Go to the other talks if you want to find out how to use any of this stuff. You should test your components with COM Plus and make sure that they work the way that you expect them to. And if there's something that you haven't been able to do in the past, check out the new calling models and the new services and see if those fit the bill for you. If you have any feedback about this or the other services that you hear about in the other talks, we do have a feedback alias. It's called comwish@microsoft.com. And I promise that we don't throw this mail away the minute that we receive it. We do keep it, we do look at it, and it's very helpful to us. So at this point, I have some, I will take questions. I have questions for you. There are some references at the end of this slide deck that point you to books about COM, references to the COM homepage, and also I was asked to put in references to training corporations who have training on, or will have training on DNA and COM Plus. So if you're interested, there they are. There's their websites. Contact them if you're interested in more training about COM, MTS, COM Plus. Okay, so let's go with the front microphone.
Okay, you mentioned the use of the catalog to either go to the existing registry or the new RegDB to determine the information about your component. And I guess my question is there something similar for registering my component so that if it's registering on a system that supports RegDB, it'll put the information there, and if not, it will put it in the standard registry?
Okay, so there's a question, is there an API that will let you, or a service that will let you register your component using the new catalog? Yes, there is, and I don't know what it is. Hopefully the admin talk mentioned it. If they didn't, You need to find Marcus or Jeff and ask them what it is. I just don't know what the name of it is.
Okay.
In the back.
I wanted to ask whether the COM Plus runtime will be available on systems other than NT5, like NT4 and Windows 9X.
Okay, so the question is, will COM Plus be available on systems other than NT5? Some of it? Eventually. I don't have any firm dates that I can tell you about when it will be available and how much of it we'll be able to put on the other platforms. The first thing is to get it out on NT5. Some delta after that, there will be something available on NT4 and Win9X. Front.
Now that there is an interface called iCancel method calls that you just mentioned, what happens to the iMessage filter, the old iMessage filter interface?
So the question is, what happens to iMessage filter now that we have iCancel method calls? I believe it still works the same way. You can still use that if you want to, but that only works for the STA case. It doesn't work for multi-threaded or neutral model.
Also, last year when I heard you, you said that COM Plus would support automatically both late bind and early bind calls on the same interface.
Were you here at the beginning? Remember that?
In spite of
everything I said.
In spite of that.
Yeah. Not in COM Plus 1.0. It's certainly something that needs to be looked at and that we are looking at for the future, but I can't give you any firm plans about when we might support that, what it will look like, or anything, basically. And if I did tell you, I'd probably have to go kill you, so
Right.
You probably don't want that. Back.
Yes. In some of the other talks, I've heard that transactions are not nestable, and yet on your slide you have that transactions are nestable and that they function independently.
Okay, so the question is about nested transactions.
Yes. Are they dependent or independent of each other?
They are independent of each other. It's not the same thing as nested transactions. When you say requires a new transaction, that the success or failure of that transaction is independent of the parent transaction.
Okay, thank you.
In the front.
I have two questions. First one is, what's the distinction between a COM pipe and a socket? Both seem like something you can read into and write, read out of and write into on different machines.
So the question is, what's the distinction between a COM pipe and a socket? And I don't know what the difference is underneath, but we have this nice COM-like wrapper where you can pass interface pointers around with COM pipes.
Okay, you can write interface pointers.
Yeah, you can pass the interface pointers around. You can call methods. Scott, do you want to add any more to that? Scott doesn't want to add any more to that, so that's the answer you're getting.
Okay, and also I just wanted to make sure I understood one thing I think you said, which was that the interception facility that's present in this infrastructure now no longer has any user interception capability. In other words, there's no way now for us to write our own interceptors and get them registered and called back when methods get called.
Yeah, so the question is there any way for you to hook in and do your own interception? And that's correct. It's not being exposed to ISVs or anyone else in this release. If you have a reason why you think you need to intercept, we'd love to hear about it so that we can figure out whether you need to be working with us or we need to do something particular in the future.
Okay, thank you.
In the back.
If you have a base client that currently supports iTransaction Context EX and you're creating two components, one that it requires a new transaction, the other component supports transactions, and today you would take that transaction context and create both components from that. In COM Plus, how do you wrap two COM Plus components into one transaction?
Okay, I think that the combination of attributes you happen to specify will not cause them to be in the same transaction. But what we're trying to do is that the context will flow appropriately. So if you're calling from an object that, and the iTransaction context EX is an object that runs within the context of MTS, so it does have a context. if you have an existing transaction context, that we would flow that if you were marked as requires a transaction or supports a transaction. And so your subordinate objects that were marked as requires or supports would all go into the same transaction context. If you were marked as requires new, you would go into a new context.
But in the case of the first component is a database component, the second component is a queue component. Currently, if we call create instance on the same object context object and call set abort, both transactions will roll back. The queue entry will be removed and the database entries will be removed. Is that so? That's true. It's just COM+ internals will take care of that from now on.
Yeah, same
Okay,
thing works.
Thank you.
In the front.
Yeah, excuse me, I got a couple questions. I thought I heard two definitions for configured and non-configured, and I wanted to cover that. One was that it seemed that that there was transaction, or there was context information associated with the COM object, and the other not. And then I heard that one was in the RegDB and one's in the registration.
Okay, so the question is whether I defined configured classes differently. Configured class is anything that uses COM+ services. The configured classes are going to have information written into RegDB.
So is there a migration path from my current MTS into RegDB then?
Yeah, when you, so the question is about migration path from MTS to COM+. When you upgrade and install your packages as they exist today into COM+,
yeah,
then we do the right thing and update the registry entries if I remember correctly.
Great. Secondly, the SCUM, and then we went to activators. Is the SCUM dead now, or is the functionality of activators in the SCUM, or?
The functionality is there. Sorry, hang on. The functionality is in the SCUM.
So the chain of activators are handled by the SCUM then? Is that what it? Okay.
No,
Nope.
not all of them. Scott's going to come up and explain how this works, because he actually looks at code and I just draw pretty pictures. Except you're going to have to stand real close.
Okay. Basically, the SCUM level is your system level activators. So things like load balancing activators and stuff run as part of the SCUM process. It's involved primarily with anything that involves cross-process, cross-machine activations.
Okay.
So that's where those particular activators go. Other activators run, as was shown on Mary's diagram, in the process and also in the individual contexts involved.
Great, thanks. And lastly, the policies, I got the impression that policies are reused, and in other words, C1 and a C2 type context policy would be reused in the same setup. When are those created, and then, depending on the answer, when are they released?
Okay, so when are they created? They're created on the first unmarshal of a reference between the two. I don't know when they completely disappear.
When the context pair-wise relationship is destroyed.
The last one then?
Last one.
Okay,
yeah.
got it. Thanks.
In the back?
You said you would only talk about DLL servers. Will the COM+ services only work for DLL servers, or are there any plans potentially in the future to have it for EXE local servers?
Right now, you have to be a DLL server to use the COM+ services. I don't know of any plans to change that. Again, if you have some reason why you would need that, please send it to ComWish and we'll take that feedback into consideration.
Okay, thank you.
In the front.
Yes, you talked about isynchronize. If you call from the client isynchronize, does your client kind of hang in limbo until the call is done, or does it just kind of let you know if there's data there or not?
Okay, I'll answer that since that's my feature. Isynchronize wait allows you to do a polling interface because you can give a 0 timeout value on it, so that you can poll and the H result will tell you whether the call is complete or not. Or you can set some finite time in there.
Great, thank you.
In the back.
Hi, do you have a limit on how many non-blocking calls can be outstanding?
Is there?
There's no fundamental limit in that. It's as many as you can get call instance objects, which is probably limited by your memory, whatever.
Thank you.
In the front.
In the complex environment, is there a difference between object pooling and object recycling?
What do you mean by object recycling?
I mean, these are the terms that I've been seeing in the slides last couple of days.
I'm not sure because I don't remember seeing object recycling anywhere.
I saw these terms in the MTS environment also.
Okay. I don't know what they meant to imply by object recycling, so I can't really answer that. Object pooling would seem to be the same thing as object recycling in that you're creating a bunch of objects, you're putting them in the pool, and during activation or whenever you need to acquire a reference, you grab it out of the pool rather than creating one from scratch. And then when you release the reference, it gets put back into the pool rather than being destroyed. Okay. Sounds like recycling to me.
For a complex component to be pooled, is there any restriction on the threading model that it uses?
Yes. In order to be pooled, you cannot have thread affinity. So you need to support the both threading model or the free threading model.
So that means that,
yep.
Does that mean that any object written with Visual Basic cannot be pooled under the complex environment?
Correct. The question is, can you write poolable objects in VB? And the answer is not today. I would give that feedback to the VB group so that they fix that.
Can a complex component, can I run it in NT4O, the backward compatibility?
Can you run the component in NT4O?
Can I run a complex component in NT4O and NT3.51? What are the issues?
Okay, so the question is about backward compatibility. Technically, you could probably run the component, but the services would not be available to you. Because your component is written the same way in COM. For NT3.51, as long as you don't try to do remoting, NT4, NT5. So if you've got more questions, let's take them offline, because I got a couple more minutes, and then I can probably answer questions for a few more minutes outside, but I really want to hear the security talk, so I'm going to run over there as soon as I can get away from here. In the back.
Well, actually, this is a different type of question. I heard you had a very good session, but hundreds of us got kicked out. So are you trying to make any efforts to repeat this session?
It is scheduled to be repeated Thursday at 4:15 in another room.
I agree, but by that time everyone is gone. So, and we have a lot of free session.
Hey, I have to stay. I don't. You know, if there's a room available and someone can figure out how to set it up, I'm willing to do the talk again.
Okay, thank you. We actually tried to talk to some of the Microsoft guys, and if you can talk to them, it would help. Thank you.
Okay, in the front.
Hi, great presentation. Quick
Thank
question. We've seen how the COM+ framework allows components that operate within it to have attributes set, default attributes, and so on. Can they be programmatically accessed, meaning one object within a package affect the runtime environment, say? I can understand, and you mentioned, I think, that you can't do that when the context has started, but how about prior?
So the question is about, can you programmatically set or query attributes,
right.
essentially?
Right.
You can query the ones which are available today in MTS through the object context properties. But not all of the properties can be queried, and I don't believe any of them can be set.
Okay. Okay, thanks.
In the back. We'll take two more questions, one in the back, one in the front.
Can you extend the object context properties at all? Like with customer properties?
Question is, can you extend the object context properties? And the answer today is no.
Will that change?
Okay, well, one correction to that. The iObject context in MTS lets you do some of this. You can still do that, but nothing else.
Okay, and will channel hooks still work?
Will channel hooks still work? I'll let Scott answer that one.
You'll want to talk to me offline.
You're in a heap of trouble, boy. Up in front.
I was interested in VB support, particularly about the pipes, whether they're going to be a VB-COM interface into something like that.
The question is about VB support for pipes. I can't think of any reason why it wouldn't work today, but there's no special support that they're doing that I'm aware of to make it easier.